In this video, we're going to talk about adding vectors with algebra, which many of you will find almost simpler to do than what we did in the last video, which was adding vectors graphically. We'll still use many of those concepts, including adding head to tail and drawing simple pictures, kind of drawing those head to tail, but we won't have to draw things to scale. We won't have to use protractors and rulers as much because the math will take care of many of those little details to make sure things are accurate. Before we can get into adding with algebra, we have to make sure we understand the algebra we're going to use. So one of the things I'm going to do here is just give you a little bit of a trig review, and specifically right triangle trig. So what I want to do is just pop up a little right triangle here and walk you through some of the things we have to make sure we know. And if you're not sure what some of these things are when we get done with this, be sure to get some help from myself to get a quick review to make sure that you're going to be able to be successful in this class. What I'm doing right now is establishing an angle theta. This is a right angle here. This is the angle we're going to reference with our trig functions. This part of the triangle, this big long side opposite the right angle here, is what we would call the hypotenuse. And then when you talk about this bottom leg of the right triangle, one that's right next to this one, that would be what we would call our adjacent side, and this one would be what we would call our opposite side. I didn't give myself a whole lot of room to write the word opposite. Okay, those should be things that you kind of are aware of. Hypotenuse, opposite, adjacent sides. We also have to know this very famous formula, a squared plus b squared equals c squared. Many of you probably knew about that right away. The hypotenuse is usually considered c, the adjacent a, the opposite b. I don't know if it matters which one's a or b, but that's what I'm going to call it because adjacent and a kind of makes sense in my mind. And the other three functions we have to become pretty familiar with are the tangent function, which is equal to the opposite divided by the adjacent, and abbreviate there. Our sine function, which is going to equal the opposite over the hypotenuse, in the cosine function, which is your adjacent side divided by your hypotenuse. That's a P. If these are things that you're not familiar with, you probably need to talk to myself and do a quick trig review to make sure that you're comfortable with this, because your things are going to pop up the entire time we're dealing with mechanics and then also in some other sections too. And if you're fighting with the math in your mind, it's going to make it tough to do things well. So we're going to move on to an example, and we're going to talk about something simple like a meteor flying through space, and there's two forces that are acting on this meteor. And just to kind of give you a picture, and I really suggest drawing some pictures to help you kind of understand sometimes what's going on. Here's our meteor. It's just like a ball of rock or whatever moving. It has two forces acting on it. One of them is a 210 Newton force that's at 90 degrees. So we know that this is going to be pushing it upwards. Oops, sorry about that. It's not very straight, but this is 210 newtons going that direction. And then the other one's at 180 degrees. So remember, based on our little axis here of 0, 90, 180, and 270, that's what these directions are over here. So we know that we're going to have one pushing it that way, and that is 150 newtons. Now, if we think about this just a little bit, we know that this is probably going to be moving off in this direction somewhere. Okay? That doesn't look like our head-to-tail method that we used earlier because it's not. We drew these tail to tail. But we know it just kind of instinctively that this should move off in this direction. If two things are pushing it, it should move off somewhere in between those two things. So what we need to do next is to kind of establish our right triangle. So I'm going to go upward, which I don't really want to use that, is my color. Sorry about that. We'll use so instead we're going to go upward and over. And I know that this one should be a little bit shorter than what that one is, but it's not super important to make it perfect. And then our final hypotenuse is going to be this one right here. I made a mistake. I'm going to get that little arrow out of here. Sometimes the smart software is a little fussy. So going back and just kind of writing these things in, this is going to be my 210 newtons. This is going to be my 150 newtons. And I'm going to erase this picture here. I want this out. Okay, so I think many of us already understand that I'm going to use the Pythagorean theorem to figure this out, which is just that a squared plus b squared equals c squared. So I'm going to say, okay, well, on the 150 squared plus 210 squared is equal to c squared. Now I'm going to let you do the calculator work on this, and I just kind of check that in advance. This is going to end up being 66,600 newtons squared is equal to c squared. Okay, c I guess would be this right here. Sometimes we'll refer that to r as a resultant. And then to get c by itself, we have to take the square root. And in this case, when I take the square root of this, it'll be plus or minus, sorry about that, 258.069 is equal to c. Well, we probably hope, I should say I hope we remember significant figures now. We only have two significant figures here in both of our numbers. So now we have to kind of round this up. So this is going to be 260 newtons is equal to c, or I'm going to call it our force in this case, our total force. So that's half our answer, because we need to figure out what direction this is going. So, and we always base that, remember, off of what we would call 0 degrees. So now we have to kind of figure out, all right, I need to know that angle. Now, in graphical methods, you would add those up. Add this 90 degrees, add this angle in here. We don't know what that angle is exactly right now. We do know this is 90, but we can figure this angle out. To do that, I'm going to use the tangent function. So I'm going to go, okay, well, I'm going to take the tangent of theta is equal to the opposite over the adjacent. Sorry about the messy handwriting, but tangent theta is equal to 150 divided by 210. Now, I have to take the inverse function of this, because I'm going to get a decimal. When I take this divided by this, it's going to be a decimal. Then with my calculator, I need to take the inverse tangent function. And again, most of you have probably done that, so we're not going to take a lot of time to do that. It comes out to be 54.4623 and a bunch of decimals. Again, remembering significant figures, theta is going to equal 54 degrees. But we know 54, if we kind of go back, is pointing off this way. We know that our thing's going up and to the left, not up and to the right. So we have to say, oh, I forgot, I have to add 90 degrees to this. That's a common mistake that many people make. So now this becomes 244 degrees. And now I have my total answer, 260 newtons at 244 degrees. And that's how you add vectors using right triangles in trigonometry.